A ball is thrown at an initial velocity of 25 meters per second at an angle of 45 degrees above the horizontal. Calculate the time taken for the ball to reach the maximum height. So our first step is write down what we are given. So we have the initial velocity u, which is 25 meters per second. We also have the angle theta, which is 45 degrees. And we also have gravity, g, which is 9.81 meters per second squared. So this is step 1, write down what you're given. Step 2 now is to draw a diagram of what happens. So we have our y-axis and our x-axis, y, x, and the ball is thrown at an angle of 45 degrees. So let's draw that velocity vector. So this is 25 meters per second, and the angle here is 45 degrees. Now, we know that in projectile motion, the velocity components in the y and the x direction are independent of each other. So because we want to calculate the time taken for the ball to reach the maximum height, we are looking at the y direction here. So let's find the velocity in the y direction, and the velocity in the y direction is given by this right angle triangle. Let's draw it in green. So this will be 25, that's theta, and this angle here is our velocity component in the y direction. And what is this? Well, it is simply 25 sine 45 degrees. So the initial velocity in the y direction, or u sub y, is equal to this, which is equal to, and let me put this in the calculator, so 25 sine 45, approximately 17.678 meters per second. Next, what do we know is also true about the velocity in the y direction? Well, we know that at the highest point, the final velocity is 0. So we can also write that down. V sub y is equal to 0 meters per second. So now let's think, which of Newton's 3 equations can we use? Well, we can use the equation V sub y is equal to u sub y plus at. Now we can sub in our values. So v sub y is 0. This is equal to 25 sine 45 u sub y minus, because gravity acts downwards, as you should know, minus g by time. And now we only have one unknown, so let's make time the subject of formula. So g, that's a terrible g, gt is equal to 25 sine 45. Therefore t is equal to 25 sine 45 over g, and t should be 17.678 over 9.81, and this should be approximately 1.81 seconds. And that's all there is to it. This is the time when the ball reaches its maximum height. And also, if you want to know the total time taken for the ball to reach the ground again, well, it's just this value multiplied by 2. That should be 3.62. And yeah, thanks for watching and hope you understood.